I want to welcome you all back. And our first presenter that we're going to have is coming to us from Germany. And let me give his introduction. Dr. Hakan Kayal, his title of his presentation is Research on UAP, SETI, and Space Technologies at the Julius Maximilians University of Würzburg, Germany. Hakan Kayal is a professor for space technologies since 2008 at that university in Germany. His current main research interests are in the fields of design, construction, and operation of space systems, especially highly autonomous nanosatellites for scientific applications, search for extraterrestrial or SETI, and research on unidentified aerial phenomena. He is responsible for several teaching courses in the field of space mission design and operations. At this university, he also is responsible for several projects. Amongst them are the SONATE 2, which is a nanosatellite, and its technology demonstrated mission for artificial intelligence aboard nanosatellites. SONATE 2 will be able to train itself in space and be able to detect anomalies at the surface of the Earth from orbit when launched in 2024. Professor Kayal is also responsible for the development of UAP detection systems and related work since 2008. The latest version, SkyCam 5, started its operation in December 2021. I'm excited to get to hear from Hakan. I think you will as well, and I'm going to welcome him right now, and hopefully he is there online with me.
Okay, I see the presentation now. Do you hear me?
Yes.
Okay, so next, please. Next slide. Do you hear me?
Yes. Please go ahead.
Yeah, next slide, please. Okay, I hope you can hear me. I wanted to start with a small motivation why I'm dealing with these topics. Next, please. And there's a quotation from Albert Einstein. I have translated it freely, and he told once that the most beautiful thing we can experience is mystery. It is the basic feeling that stands at the cradle of true art and science. Whoever does not know it and can no longer wonder, no longer marvel, is dead, so to speak, and his eye is extinguished. So I agree with this. I think mystery is something wonderful. This is one motivation. Next, please. There's a second motivation. You can see it as an inscription on the main building of the University of Würzburg, and it says Veritati. So this means something like committed to the truth. And I think we need both. We need to deal with mystery things, but we also need to see the truth. And next, please. So another thing which was interesting for me was the life itself. Next, please. And for that, I have been at a conference in 1980. It was an astronomical conference in Istanbul. And there was a small presentation from a young scientist who talked about theoretical possibility of life building blocks on comets or asteroids. Next, please. And the reactions from the conference was that this presentation was very unserious, and there were most violent protests. So how could he present such an unserious thing? And that was 1980. And then 2015, the Rosetta mission with the Philae lander was very successful. It landed on an asteroid, and it found some building blocks of genetic molecules, DNA and RNA. Next, please. And now in 2022, some weeks ago, there was a new study which showed that now all basic building blocks of life have been found in space already. So theoretically, it is now considered possible that life could have come from space, because all of the building blocks are already present and have been found in space out of the Earth. Next, please. So, and also, I'm sure you know all that at the moment, more than 5,000 exoplanets have been found currently. Next, please. And so all of these things are very interesting to me since my childhood. But after my study of aerospace engineering, I went to Turksat in Turkey and operated a commercial communication satellite. That's what you see on the right bottom side. And after 1 year, I switched back to Berlin, to Germany, and worked in the frame of the so-called BIRD project. BIRD stands for Bispectral Infrared Detector. It's an infrared detection satellite. It's a small satellite, as you can see. And on the left corner, you see some spots. These are Easter fires in Austria. And we were able to see them and to calculate the energy which comes out of these fires with these infrared images. So it was a very successful satellite project. And then later I went to the Technical University of Berlin and dealt with other more smaller satellites. Next, please. And now at the University of Würzburg, where I'm now since 2008, we have aerospace information technology and bachelor and master study program, and we have also a satellite technology program and also a computer science with focus on aerospace. Currently in preparation is a Center for Artificial Intelligence and Data Science. This will be a very large center at the University of Würzburg. Next, please. I have brought to you some slides showing what we are dealing with the students. So I have some student project examples now. You see we are designing satellites like this one. Next, please. But we are not only designing satellites, we are also dealing with bases on the moon and on Mars. Next, please. And next. Next again. And together with students groups, we are making semester projects. And at the end of the semester, the students are presenting their findings and their studies, how to design a moon base, for example, or a Mars base. Next, please. Next. But we are doing also work related to hardware. This is an example where a student has set up a small telescope with software, of course, to detect the transient lunar phenomena on the moon. Next, please. They are dealing with software which we use to communicate with satellites. Next, please. We are dealing also with megastructures, with large structures, which are supposed to be built in the next decades around in the cislunar region, around the moon, for example. Next, please. We have a small telescope in Spain, which is remotely operated from Würzburg with the same purpose to detect the transient lunar phenomena on the moon. These are short-living luminous events on the moon. And students are building software to detect these short lightning events on the moon. Next, please. But they are also building multi-sensory systems for automatic creation of thematic maps. For example, this was a project which was flown on a Bexus balloon, which was supported by the German Aerospace Center, DLR. Next, please. We are also building payloads for small model rockets, which we buy, but the students prepare experiments on them. Next, please. If you want to make larger experiments on rockets, like sounding rockets, then we have also the possibility for this. We have done this several times now, and here also the German Aerospace Center, DLR, supports these tasks. These sounding rockets fly at about 80 to 90 kilometers, so almost reaches the space. And one of the experiments was, for example, detection of the Earth horizon using image processing techniques automatically as an experiment on the sounding rocket. Next, please. But there's another example which deals with the landing on a planet without parachute using the same technology like Maple seeds. And you see my doctoral students, Clemens Riegler. He is the leader of this project, and he prepared, together with others, of course, these seeds, and we launched them. Next, please. And 2019, next, please. We launched these seeds, 3 of them, on board of this Rexus rocket and released them. And so they came down to Earth and landed finally on Earth. Next, please. So this was all about teaching examples. Now regarding research focus in my professorship, I'm dealing with development, construction, and operation of space systems, as I've shown, especially for interplanetary exploration later, especially for higher autonomy. And my third point research topic is SETI and research on unidentified aerial phenomena. In the last 10 years or so, I've dealt more with the first 2 topics, but since about 2 years now, I've intensified my work on the third topic with the UAP topic. Next, please. But we are still, of course, building satellites. One satellite was Sonate. Sonate was launched 2019, and we have successfully operated it for about 1 year. It was a 3-unit CubeSat. Now we are working on Sonate 2, the follow-on mission. Next, please. That is the main objectives of Sonate 2. It's a demonstration of artificial intelligence technologies in space on board of a small satellite. It's a nano satellite with the size of 6-unit CubeSat. We want to demonstrate that it is possible to train the system in orbit. So this is something new. Normally you train the systems on Earth and then use them in orbit, but we want to train it on orbit. And one of the purposes is to make it possible to detect anomalies from orbit. And we can imagine to use such technologies in the future for interplanetary exploration. So if we want to find something new, something unusual, something anomalous, then this type of technology would be helpful. It will be launched in the first quarter of 2024 and is also funded by DLR. Next, please. Here you see some current images from the development of the satellite. We are developing our hardware by ourselves. Next, please. Next, please. Here it is very difficult to see. You see almost nothing, I guess. These images supposed to show some geometric forms which are detected by the artificial intelligence, which is difficult to detect. Next, please. Next, please. Okay, we have some laboratories where we support the development of the satellite. We have a clean room, we have a shaker, mechanical shaker, we have an air bearing table, which is needed to simulate the magnetic field of the Earth. So we have, in fact, everything which we need to test the satellite on ground. Next, please. Maybe you can start the video if it is possible. Left and right, these are videos, in fact. Okay, left also. So you can see some videos of how we test the things. If you can start the video on the left side, then you will see how components are shaped, because when you start a satellite with a launcher, with a rocket, then there are a lot of mechanical shaking taking place, and you have to test them on ground that your satellite components will survive the launch of the rocket. Next, please. We have also a ground station from where we command and control our satellites. This is one of the ground station antennas in UHF and VHF. Next, please. Next, please. We have also a S-band antenna for Sonate where we can receive the image data and video data. Next, please. We have a mission control center from where we control the satellites, and this has been used for the Sonate satellite already, and we will use it, of course, for the follow-on mission Sonate 2 also. Next, please. This is an image from Sonate from, I think, 2019, where we operate our satellites from. Next, please. Okay, regarding SETI, there is more, not so much hardware work, but more paperwork. I've published some paper regarding SETI, and we have also made a conceptual design of an optical SETI satellite, for example. And we wanted to know if it is possible to make optical SETI from on board of a nano satellite, a very small satellite. And the answer was yes, principally it is possible, but it must be investigated further. So there is less work which we do in the direction of SETI. We want to combine satellites, especially small satellites, with search for extraterrestrial intelligence. Next, please. So now I come to the topic of UAPs. Next, please. I think we can almost skip this page. You know the difference between UAP and UFO. I think I don't have to repeat it for you here. I find the expression UAP better, really, because it's a more general term than UFO, because UFO suggests that it is an object, but in fact it could be also another phenomena, like weather phenomena, even if it is not an object. Next, please. Next. So, but these phenomena are not new. For decades, we have seen such phenomena. It has been reported about it, and most of the observations can be explained easily if we have enough information and if we have experts on it. But I think there's really a small part which is remarkable. Next, please. And should be investigated. And if I say small, what do I mean with a small part? I can refer to this chart from GPON, from CNES. This is the French government space agency. They have a division which is called GPON to investigate UFOs or UAPs. And they have about 3.4% of the observations they received, which they cannot explain, although the information database seems to be good enough. Next, please. Maybe I can tell also from Germany, I have recently talked with the leader of an association here from Germany, and from his experience, he can tell the same. So about 2 to 3% of the cases which they receive can be classified as a UAP. So that's the same magnitude of order. But the question was, since several decades, is there a need for UAP research really? Scientific research, is it really necessary? And from my point of view, I think yes, it is necessary. Because I think very documented cases are interesting for science because they carry the potential for discovery of previously unknown phenomena. And this potential justifies investigations in particularly outstanding cases. Of course, not the 90-70% of the cases, but for the rest, for the maybe 2 or 3% of the cases, it could be something really new. And this is justification enough for me to deal with it seriously. So what we need is we need an independent, unbiased, open, and rigorously scientifically sound investigation of such observations. But we have many difficulties. Often we lack of objective, robust data. And also, as well as contextual information is very important. And in many cases, we don't have this contextual information. Obviously, occurrence of the phenomena is not repeatable, not predictable. Airspace monitoring is relevant to security. We there is a need for secrecy, of course. And also, additionally, many observations in the past were ridiculed, concealed, or kept secret in the past, consciously or unconsciously. So there were, of course, also deceptions too. And these and other aspects led to the stigmatization of the topic. So, and in this environment, the scientific community, often with regard to their academic careers, hardly dealt with the subject at all. So they didn't show interest to these cases. Next, please. I think you all know what UAPs makes interesting. I think most of the important aspects are the extreme accelerations or maybe speeds. And also the flight characteristics are very interesting in the absence of sound or audio. And but I think the most important aspect is that when we have such interesting observations and they are carried out simultaneously by different instrumentation and radar and optical and infrared and so on, then it gets really interesting. Just one observation by one human is not so interesting as an observation where we have different kinds of instruments at the same time looking at the same phenomena, and still it behaves very strangely. Then it gets, of course, interesting. Next, please. You know this too, I guess. There are very few analysis of UAPs because there's few data, but this is one of them. I think you all know this. This is just a good example that meaningful investigations could be done. It is possible, provided that we have really data and data is available. So this is just an example. This shows that serious investigations can be done if we had data. Next, please. What the UAPs, the real interesting ones, show us is can maybe shown here, compared here. I see our technological situation on Earth in the area of aerospace like an ox cart on the left side, compared to what we observed, what UAPs do. Obviously, with the International Space Station. So there is a huge difference. They behave like if there was no gravity or I don't remember the other word, but if the UAPs, or at least some of them, were technological origin, then the difference is simply huge. Next, please. The word was inertia. I wanted to tell that they behave like they don't comply with the inertia of mass. So that's why they can do such extreme accelerations. So this is all interesting. And some months ago in a German radio program, I was asked, this is all very interesting. So there should be extensive studies already. Why is it not so? And I told to him, no, it's not so. There are no extensive studies about this from universities in the scientific community. And I think the four main reasons are here. You can see them on the left side. There are security interests, which is understandable, but it is so. There is poor data availability because of the same reasons. And there is, of course, the unpredictability, and this all leads to the stigmatization. And instead, we had, since 70 or more than 70 years, many UFO books. This was the main source of information about UFOs. That's, of course, not good. Next, please. Next. So the question was, over 70 years, do UFOs exist or not? And the answer was still, all the time no. So next, and many next. It will repeat now, next. The answer was always no. In between, there was this Condon report, which told that it's not so interesting. And in between, the answer was always no. And then some, maybe 10, 20 years ago, the answer was maybe, because some of the countries in the world, including Canada, for example, or Great Britain, England, has published at least some of their files regarding the UAPs. So the answer was maybe. And then, next please. Finally, last year, next please, we got the answer yes. And surprisingly, next please. So what happened? Next please. And what I think you all know what happened. There was this Advanced Years with Street program, which was published by New York Times. And we heard about this Unidentified Aerial Phenomena Task Force from the United States. Next, please. And there was some people at higher level which told that there is something, but we don't know what it is. Next, please. And you know this report from NDI tells that UAP do exist, but we don't know what they are. And it tells that they must be further studied. Next, please. And that they cannot be explained mainly due to limited data. So it repeats that we need more data to explain them. And interesting is that it also states that there was a social cultural stigma, and it was problematic to gain more data on UAPs because of this stigma. Next, please. And what happens after the DNE report? I think there's a growing concern, and for this reason, there was this new agency in the United States, which will be set up in these weeks, I think. And obviously, like Mr. Graves told in the ZDF documentation in Germany recently, some weeks ago, there are more material than publicly known. I'm sure that this is true. Next, please. And also we know that there's a concern regarding the flight safety of airplanes, military, but also civil airplanes could collide with these UAPs. At least they are dangerous because they are not controlled by flight controllers on ground. Next, please. And one question is, there was a hype in the last maybe 1 or 2 years because of this DNI report. But is this all new? And the answer is definitely no. This is absolutely not new. In fact, the reports we have seen in the past 1 or 2 years are very similar in my eyes to those we have read about or heard about in the last decades, many decades, in fact. And for example, on the right side, you see there's an interview done by MUFON, Central European Section. It's an interview with the Lufthansa chief pilot, Werner Utter. And in his interview, he tells a story about a case where he has seen a UAP in the 60s, I think. And it was very interesting because the object came directly in flight towards him, towards his plane. And then it remained between the left engine and the cockpit and flew with the airplane together in parallel. And then it flew in the opposite direction against the sky and vanished. So that's it. So it came from the opposite direction, was between motor and cockpit, and then flew away. And this event took about, I don't know, 3 to 5 minutes, maybe 4 minutes, he explains. And they were shocked, of course. His co-pilot and engineer all saw everything. And so this is just one example, and there are several other similar examples. Next, please. So it's not new. So the current situation, there's a changing in the thinking because of all these reports in the past 2 years. So the mere existence is not doubted so much anymore. And this is really important. So we can now deal with this topic. You know all, I think, the Galileo project from Harvard, which started now. And there's this new agency, which is going to start in the summer. So I think we can expect many benefits for science and for the society, independent of the possible results, whatever comes out of these investigations. And the phenomena, in fact, is a worldwide phenomena, not only in the United States. Also here in Germany, I get more and more reports from people. I can show you how it looks like. Sometimes you will not see who it was, but I get such letters on paper, handwritten. And this is taking more and more place. I think there are many people who didn't report also in Germany in the past such things because they were simply afraid of reporting because it was so strange. But the main problem is the data situation. We don't have objective data which we can analyze. Next, please. So in Germany, there are now more increased media reports on UAPs, especially due to the activities in the United States. And there is a slightly increased public interest also. But in Germany, there is no dedicated or central governmental institution for UAPs. In French, for example, we have the GPON, and there are some other countries who also have institutions which at least cooperate with the governmental institutions. But in Germany, we don't have such a thing. There are, of course, private associations such as GEP or DEGUFO and others. Also, there are some blogs like Grenzwissenschaften, aktuell.de, which are all very successful and very serious, but there's no governmental institution. And we have also one interdisciplinary group, which is called ETI, which deals with SETI and its derivatives. It's called Research Network Extraterrestrial Intelligence, where I am a member of too. It is also dealing with UAPs recently, but that's it. And from the university's point of view, there is only one exception. That's my university, Würzburg. There's no other university in Germany, of which I know at least, who is dealing with UAPs. And at Würzburg, at the University of Würzburg, I have this research topic since 2008, where I came to the University of Würzburg. And since then, since 2008, I have this topic. And recently, at 25th of January this year, it is officially part of the Interdisciplinary Center for Extraterrestrial Studies, IFEX, at the University of Würzburg. So finally, the Senate of the university has accepted that UAP topic will be part of the university's research topics. In addition to that, I brought the UAP topic to the Extraterrestrial Studies section of the German Society of Aeronautics and Astronautics, DGLR, which I'm leading. The DGLR is the largest aerospace association in Germany. And I have taken now the UAP topic into the Extraterrestrial Studies section 2 now. So this is all what we have in Germany right now. Next, please. The reactions of the media to UAP in Germany has, as I told, changed a little bit, maybe much even. In the past decades, it was a stigma too. So they were laughing at that topic when there was some cases about UFOs or UAPs in the media. But now it has changed, and some of the recent reports from the media, from Der Spiegel, for example, or from ZDF, has seriously reported about this topic and don't laugh anymore. Next, please. Yeah, this is just to show that it is now part of the IFEX Center. Next, please. Next, please. What we are planning to do in IFEX in the center, getting more increased public attention. We have increased case reports coming in. We need, of course, more resources to handle them. We need to apply for funding, because without funding, nothing can be done. We have to strengthen the organizational structure of IFEX. We also want to look at old but important cases to support the development of future sensor systems. So I believe that it is important not to neglect old cases. We have to look at them as much as we can, and we have to learn from them as much as we can, so that we can develop new sensor systems adapted to the phenomena. Because I think this is the key thing we have to do. We have to develop really very, very innovative and new sensor systems adapted to the phenomena, which we don't have yet, because we don't have enough information to the phenomena itself yet. So, and of course, we have to develop and operate sensor systems. We have to conduct interdisciplinary studies, develop national in Germany, and of course, international cooperations. And we have to, as IFEX, coordinate activities in Germany together with local authorities, and further raise awareness and advising also policymakers on the UAP issue. This is what I'm trying to do in Germany. And we have to communicate the results also with the public. So public science communication is important. Next, please. You can skip this. Next, this is just from the DGLR, but I've already showed. This shows one example what I've done in 2008 or 2009. This was one of the first tasks, in fact, what I've done when I came to Würzburg as a professor. The first thing I've done was to set up a camera for UAP detection. And then I've started with the satellite topics. Next, please. We had a small project called ASMET to detect meteors, and the software which we have developed to detect meteors could also be used also for UAP detection. Next, please. We have a setup at the roof. And to detect unknown phenomena in the sky, my philosophy is that we have to know what we know. So known aerial phenomena. So we have to know everything about what we can see in the sky, beginning from objects far in the space to objects in near Earth space, in the atmosphere, near to the ground, and also on ground or on water. So we have to know all the objects which could be seen, can be seen from sensors. Next, please. The ASMET was the first step. You see here some pictures from the graphical user interface. Next, please. We have used this system also in Norway, in Hessdalen, because maybe some of you know that in Hessdalen there are these Hessdalen, so-called Hessdalen lights, which could be also a kind of UAP. And that's why we have set up an observation box in Hessdalen 2018. It operated about 1 year, but then shortly after that, COVID came, and then we couldn't replace it because it's at the moment not working. Next, please. So when we look at the sky, we see many, many objects, but surely not UAPs. So we have to detect them. We have to understand that these things are not UAPs, but insects, raindrops, and all the other things. So we have a lot of really, you can believe me, practical problems when we observe what is going on in the sky. Next, please. This shows these core components of observation systems, which I have proposed in 2009 in my paper, Hyper SETI, a new way of searching for extraterrestrial intelligence. Next, please. It is basically built of multi-sensors on the left side, visible, near-infrared, infrared, ultraviolet, spectrometer, and so on. We need a pre-processing unit and to make fusion of all of these data and control them, of course. We have a neural network system which tries to classify the objects which we see. And next, please. And if it is important enough, we should also have a tracking system to get a closer look, also with different types of sensors at the object. Next, please. And as you can imagine, we need a lot of software and also a lot of money. Next, please. Next, next, next. Some of the two green symbols you see we have already done, and which is what is not green we have not done yet. Next, please. You see the SkyCam 5 system, which we are operating now since December last year. It is on the roof of the building and at the campus here, 100 meters away from me. And it is remotely operated from the Mission Control Center, which we also use for the satellites you have already seen a few minutes ago. On the right side, you see the part of the Mission Control Center, which is dedicated to UAP detection and also to control and operate the TLP detection telescope in Spain. So the same room, in fact, is divided into two parts. In one part, we are operating our satellites, and in the second part, which you see here on the bottom or on the right side, we operate our earthbound systems. Next, please. Here you see a GIF animation of how it looks like when the system automatically detects objects in the sky. It automatically classifies it using the deep neural network, and then it tells if it is a bird or something else. And if it is not a known object, then it is automatically classified as unknown. And at the moment, when the system works, then it detects about 5 to 10 unknown objects per day. But this is normal because we have not trained it yet fully for all the objects which we already know. So in future, it will be trained further. And so the objective is to decrease the alarm rate maybe to 5 objects a day, because this is a number which somebody can look at. 5 cases a day is you can handle it easily. So we are trying to decrease the alarm rate. Next, please. Here I brought some videos. Next, helicopters. This is in day. This is just to show you. Maybe you can run the video. Okay, it's running. I'm showing you these videos just to let you see that how difficult it can be to detect automatically objects in the sky or UAPs. Because also you have raindrops, you have bad weather, you have insects, you have everything you can imagine in the sky. And they are producing alarms. And sometimes it is difficult, although we are using artificial intelligence to sort them out, because you risk also when you sort them out too fast, then you risk that you lose maybe real UAPs. Next, please. Here you see raindrops on the right side. So we have a lot of technical problems, not problems, but issues which we have to solve. So we have to reduce false alarm rate, and we have to do verification to multiply in different types of sensor technologies. Also, of course, using sensor networks, so that at least 2 or 3 or more sensors look at the same region of the sky, so that we can reduce further false alarms. But nevertheless, it's a question of resolution, frame rate, processing speed, exposure, sensor artifacts, optical errors, reflections, insects, flowers, drops, and many, many practical issues we have to solve until the system works so that we generate very few false alarm rates, and we can wait for the real UAPs in regions like Hessdalen, for example. Next, please. these are two more videos. On the right side, you see something which comes a little bit close to a UAP, but it is missing some interesting aspects, which I have told before. For example, it is not abruptly changing its direction. It has no acceleration, which is dramatic. It looks like a normal acceleration. So it is not very exciting, but it looks similar like that. What we want to see is something like this, but with the characteristics of a very interesting UAP. Next, please. Because we can imagine that we should have many types of sensor systems. On the one side, very expensive but very good sensor systems, but on the other side also cheaper versions of that. We are working currently on this cheaper version too, in parallel to the expensive version. We have called it the window version because we can imagine, to put it simply, in the window of an office, like my office here, for example, and to let it look out from the window. And we can distribute it to many people. Then it has, of course, lower performance, but larger units, number of units can be used as an addition to the system. And it will be, of course, part of the network. The first prototype is already almost completed. In this summer, it will be completed totally. And we can then hopefully begin to distribute it. Next version, please. Next, please. Here you see Mr. Herbst, who has developed now the system. He's holding it in his hands. It's that small. And on the left side, you see the control center of the software. It's a client software from which we control the sensors and where we get the image data. Next, please. I have added some examples of infrared images. Some months ago, I've bought a commercial infrared glass just to make some experiences with it by using with my own hands. Next, please. And I've made photos of the moon, for example. Next. Here you see clearly it's the moon with some power lines. Next, please. Next. And this was an interesting object in the sky. Also last summer, I think. It looks strange. So we didn't first know what it is, but next, please. When you get a wider view, next, please, then you will immediately see what is going on. This is what I mean with context information. When you look at this infrared image, you immediately can understand what this should be. It's a balloon, of course, because you see a normal balloon on the right top side. So this other object on the left side is also a balloon, which looks like a tool. But you understand this because you see the context. But from the first image I have shown to you, maybe you didn't understand it because you didn't see the context. Next, please. And also, next, please. I've made experiments with this commercial glass and watched some airplanes in the sky. And I think it's a video. Maybe you can play it. No? Okay, then go back, please. Because some people are angry about the videos which can be found on internet. Sometimes they are blurry, they are low resolution or bad quality and so on. And for me, this is normal because these are in the cases where we use infrared sensors, we have low resolution. And if we have people who are making these videos, of course, they are shaking too. So we have shaking, bad quality, low resolution infrared images. Yes, this is what we get when we use such instruments. Because in the case of infrared images, we unfortunately don't have high resolution images. This is from the technical point of view today, at least in the civil Bereich, simply not possible compared to the optical range of sensors. Next, please. In Germany, I think it's a first of its kind in Germany. I have created some weeks ago a new publication series dedicated just to UAPs at the university. We have a library, university library, and they can set up new publication series. And now we have a UAP publication series. And the first publication within the series was published also some weeks ago. It's, where's the title? It's detection of UAP with a nanosatellite. Yeah, that was the publication number 1. And then I hope that we can continue now with this series of publications. And in the future, we will make publications here within the series. And they have a document object identifier, this DOE, so everybody can find it in the internet. And in the future, we will make more publications using this tool. Because, of course, we will in the future make also publications regarding our research in peer-reviewed journals, but not everything is really worth to be published in journals because the quality is different. This is a work from students, I should mention. So it's not worth to be published in peer-reviewed journals, but we have a publication device now with this tool. Next, please. There is a very, very long list of to-do, what we have to do in IFAX. We have to implement complementary methods, for example, by using passive radar. There was a student work in 2019, for example. He was very good. It was a bachelor thesis, in fact. He used passive radar to detect airplanes and meteors, and I can imagine to use this also for UAP detection in parallel to the other sensors. And of course, complementary sensors like spectrometers, infrared, and so on. We are working on a tracking system also. We have a association here in Würzburg, at the University of Würzburg. It's called WUSpace. The students who are working there are also working on a tracking system for rockets. And the idea is to modify this rocket tracking system so that it can detect also or track UAPs. One of my doctoral students is working on this topic right now. Next, please. Next. So next. Okay, so next. This almost last slide tells something about the significance and consequences of results of new investigations. So at the end, when we, after we have finished our investigations, maybe we will find out that everything regarding UAPs can be explained by secret Earth technologies. So I think if this would be the answer and the result, it would be okay, because it would be possibly a quantum leap in different technical sectors like energy, transportation, and communications, because we would then be able to use these. This is the hope, of course, my hope. We could use then these technologies in the civil area. So also, it would then be acceleration of human presence in space, I guess, if we find out that all of these UAPs are based on secret but earthly technology. So that would be a good result for me. The second case, it could be also, it could be a natural phenomenon. In this, in the simplest case, we would have a better understanding of natural phenomena such as ball lightning, which is still not solved, or maybe even discovery of new type of natural phenomena. And this could eventually help us to extend our physics to potential contributions in the form of unification of theories about the four fundamental forces. So what we are observing in the sky, the UAP research, could in fact contribute to the unification of the four fundamental forces. Because what we are observing is so extreme that the investigation and the solution of UAP problem could bring us one big step further into the direction of unification of the four fundamental forces. So this would also be, from this point of view, a good result. And the third possibility is if the first two fails, if we cannot explain UAPs with Earth and secret technology, we cannot explain them with new natural phenomena, then it might even be that it is of extraterrestrial origin, extraterrestrial intelligent origin. We should not rule out this possibility. And if this happens to be true, of course, in any case, we would have very far-reaching consequences for science and society. Next, please. So this is my summary. We have at the moment a paradigm shift because there's a more increasing acceptance of the UAP as a topic without laughing a bit at it. And obviously there are more sightings than publicly known, and this worldwide. It is an old phenomenon, more than 70 years, maybe much more, but it is new to science, or it looks like new to science. And there's an increasing consensus that scientific research on UAP is needed. I think more and more scientists come to this conclusion and will start with their investigations too. And I expect large benefits to science and society regardless of the potential outcomes. And there's a need for iterative development, expansion and operation of novel technical systems for objective data collection. This is what we really need to do and can do. And this should also include space systems. And all of this can only be done if we have enough money. So there's a need for significant research funding, also from the states, from governmental side. We have to expand the network of experts from all disciplines, cooperation with existing and future organizations. And we have to use existing know-how because there are a lot of people who have a lot of know-how on the topic. We should not throw this away and use this know-how. And we need to permanently establish interfaces with relevant governmental agencies and research institutions. I know this is very difficult. I'm trying to do this in Germany too, but I know this is not easy. So in the case of IFEX, what I can do is to have the role of coordination. So coordination and execution of investigations in particularly outstanding cases will be done by IPEX, by our center. And I hope that in the future we can expand our center and make also relevant interfaces with governmental institutions and also get funding, of course, so that we can increase our investigations early. And then, of course, science communication with the public. So next, please. So this is my last page, a quote from Arthur C. Clarke. I like it very much. That's why I show it to you here. If an elderly but distinguished scientist says that something is possible, he's almost certainly right. But if he says that it is impossible, he is very probably wrong. So that's my final word. Thank you.
Hello. Hakan, thank you very much for an excellent presentation. I'm just, there's so much there to absorb. It's amazing. Hakan is going to be joining us again tomorrow when we talk about academia and UAPs. So I'm proud that he's going to be able to do that, as is our next speaker, Alexander Wendt. Hakan, if you can address some of the questions that we've got. Do you have time?
Yeah.
Yep. One of the questions is, could you weigh the cost-benefit analysis of these smaller and cheaper satellites, which can get up there to study UAP and SETI, but which are more likely to break down and become space junk and orbital clutter? For For robust long-term satellites, radiation-hardened microchips and other expensive engineering-intensive hardware is very crucial.
These are different aspects. I think there can be a good cost to, what was the word?
It says that they're microchip hardened satellite microchips, radiation hardened microchips, excuse me.
Part, okay. For the first part, I can tell that small satellites are getting more robust. So we can observe that more and more topics which could not be imagined maybe 20 years ago are contributing today in the context, for example, of Earth observation, communication, or navigation. Small satellites are more and more used because they are getting more mature. So it's not, I think it's not correct to say that we are contributing to space junk with small satellites, but we are more and more able to contribute to really good applications with small satellites, and we can let them fly in a relatively low Earth orbit, so maybe below 500 kilometers, so that they don't fly too long in orbit. They come back to Earth within several years. And also we can use techniques to let them go down to Earth relatively rapidly if we command them to do so in the future. So regarding satellites in low Earth orbits, hardening of the electronics because of radiation is not a big problem. It's more a big problem when you go to outer space, to exploration, to Mars, Jupiter, and so on.
In a similar context to what you've just said about the protection of the equipment and everything, it says, I've read that anomalies in infrared satellite data are filtered out, with the assumption that anomalous data points are caused by cosmic rays that are hitting the sensor. Is there any efforts to collect and analyze anomalous data that would otherwise be ignored?
We have, many years ago, I had a student work. I think it was a bachelor thesis. We have analyzed Meteosat data, which is normally delivering Earth observation data from the whole Earth. And every 15 minutes, one image of the whole Earth for meteorological applications. And we have analyzed the images there automatically to detect something anomalous. So yes, it is possible. And there are also many other high-resolution satellites which are imaging the Earth. But the problem is that most of them are not really suitable for UAP detection, because many of the Earth observation satellites use, for example, line sensors, which are flying over the Earth, making a scan. So they are imaging, making an image of one place only for a fraction of a second. So it is almost impossible that you detect at that moment a UAP. So most of the Earth imaging satellites are simply not usable for that purpose. I think we need satellites which are dedicated to detect UAPs, and that's why we have performed this study and published it some months ago.
Can you provide any information on transient lunar phenomena?
Transient lunar phenomena, these are short lightnings which appear on the surface of the moon. And there are maybe 10 or 12 theories how they could be done. So we think there are many natural sources hitting parts on the surface of the moon, for example, is one possibility. But electric discharge is another possibility. outgassing is another possibility. So there are a lot of hypotheses how these transit lunar phenomena happens. They are observed since many years now. Regularly, there's an ESA from the European Space Agency, a telescope in Greece, which is, for example, observing the moon all the time. And they are finding a few TLPs every month, I guess.
Are you engaging the European Union and or the UN's Office of Outer Space Affairs to facilitate any international cooperation on this issue?
I've tried it. Some years ago, there was a conference, the International Astronautical Congress, and I attended that conference. And I was sitting at the same table with the head of UOSA. And I made that proposal, of course, and the answer was, it is very, very difficult because the nations must demand for this. So she can't do it. Or at that time, she told me that she can't do anything unless the countries themselves insist on working together. And as you can imagine, this will be very difficult. But nevertheless, I think we should try. Yes, I will try.
Are you, by chance, working with Beatrice Villarreal in respect of objects within geosynchronous orbits around the Earth that have been discovered by the Vasco network?
No, not yet.
Also, do you happen to publish in any respective journals any of your work?
We are going to publish, yes. But I think it will be more worth publishing in journals if we have really results. Because we can, of course, publish about the work we have done so far, but we will then only describe the systems we are using. So this is not much. For my feeling, there must be something. There must be some results, and then it is worth of publishing. Yeah.
With the Skycam 5 cost, is it cost effective or available to be able to deploy, I guess? And is there any qualifying criteria such as location?
We would, when we further develop it, it's a test system at the moment. We are using here at the campus, as I told, because we are close to it. We can handle it here. But of course, it should be set up in an environment where we think it's a hotspot, where we think there are more UAPs, and like in Hestalen, for example. And it's not cost effective, it's expensive. And I think systems like Skycam with high performance will not be cheap. Skycam 5 itself costs around 15,000 euro. Very simple system currently.
You speak about the algorithms that you used in terms of anomaly detection.
Yes, we are using the algorithms to classify the objects we know. And if we detect something which the system thinks it doesn't know, then we look at it as a human. So we are trying to reduce the false alarm rate by detecting birds, for example, because birds are the most objects we observe.
Let's see. I'm trying to go to the next question here if I can get to it. I've read that anomalies we have already talked about that. I think that we've pretty much answered those. Are there any scientific funding bodies in Europe that are willing to support your sort of work?
I don't understand the question.
Are there any scientific bodies in Europe that are willing to support the study of UAP or do UAP research besides yourself?
In Europe, yes, there's in French, for example, this GPON, who are doing this since, I don't know, 70s or so since many, many years now. Yes, the answer is yes. But in Germany, it's, I think what we are doing in Germany is unique, but in Europe, there's this GPON in French.
One question here is, will you be re-looking at the Belgium wave flap to correspond to sightings in Germany around the same time?
I didn't clearly understand the question.
All right, well, I think that's pretty much in terms of the questions that we've got right now for the time that we have. I want to thank you for coming on with us, and I'm sorry about the technical issues that we had, but I'm glad that we got it all worked out, and we're going to move ahead on the schedule and go to the next presenter. But again, thank you again for all of your work, and we appreciate your time.
Thank you.